All right, so in this lesson, let's learn how we can factor some special products. The first one, allow me to write it out. All right, so the first type or the first special product I would like to introduce, a perfect square trinomial. Okay, so what exactly is a perfect square trinomial? Allow me to bring in a problem. And at this point, after you have learned from the earlier lessons how you can factor a quadratic expression, I'm gonna keep referring to those. Okay, so bring in as much as possible of your understanding in terms of how we can factor a quadratic expression. Okay, so let's not be too worried about what a perfect square trinomial is, and then let's look at one problem simply as a polynomial, as a quadratic expression. So how about we have capital X squared plus 2xy plus y squared. Let's factor as a problem for everyone to look through right here. Let's factor this quadratic expression. It is clearly a quadratic expression, just like any other one that we have done previously from our previous lesson. And so the only thing a little unusual is that I'm using capital letters to name my variable, but that shouldn't be any problem. I have a purpose as an instructor. I have a purpose of using capital letters right here. But the main point now is that it's what I want to remind you. This is a quadratic of two variables. There's the x, there's a capital X variable, and there's the capital Y variable, and it's simply just a quadratic expression. And so it's called a trinomial simply because the expression here got three terms. So that's what a trinomial is. But then being a perfect square or not, we're going to get to that. So right now all I'm seeing, it's a trinomial, and it's clearly a two-variable quadratic expression. That's what we have here. And then leading coefficient 1 or leading coefficient other than 1, you already know how you can handle this. And so from your understanding, from your past learning, and right in this course just before this lesson right here, then allow me not to go into too much detail now, because I'm assuming that you have already mastered the skill. So with a quadratic expression like this, I am sure with your skill that you have previously learned, this can be factored into one pair of parentheses, being x plus y, in product with another parentheses, another pair of parentheses, x plus y again. Feel free to pause the video and verify your work, verify my work, using your own work, using your own understanding from the lessons you've done prior to this lesson right here. All right, so now at this point, hopefully you have resumed and had your own time to clarifying what I've had here. But now a little further observation, I realize. So this is a little bit beyond what we have learned from the past lessons right here. We realize, hey, wait a minute, these two are identical factors. These two, it's just so from here to here what I meant, and I intentionally use the methods we've learned from the previous lesson, and anyone can do this. But then from now we're looking at a little more closely at our final products right here. At our final products, we realize that, hey, this product here has exactly two identical factors. And so in that way right here, we can algebraically re-express, we can rewrite all of this as, anytime we have learned that long enough, up to this point, anytime we have identical factors, we can rewrite it as just simply one of that factor. So x plus y, we only need to write it one time, but we put the square here. All right, so now I've come to a realization. Hey, wait a minute, so it looks like x squared plus 2x times y plus y squared. This quadratic expression can be factored into a product, but this product is a little more special than those we have seen before. It's a product of two identical factors, or for short, it's just x plus y all squared. Okay, and so ladies and gentlemen, this is the reason why a trinomial like this is referred to as a perfect square, because after factoring, it comes into an actual square, a perfect square of some other the little factor. All right, and so now that's one of them. And I'm not exactly saying how useful this can be yet. But I just point out that from now on, a lot of times, x squared, when you're seeing x squared plus 2 times xy plus y squared, we can easily recognize that into x plus y all squared. All right, and so allow me to bring in another one, because perfect square trinomial, this is one of them. This is one among them. Let me bring in another one. So how about we can have an x squared, and again, just think of what I'm doing here as simply a quadratic expression like you've done in your previous lessons. The only thing unusual is I'm using capital letters for the variables. X squared minus 2xy plus y squared. So let's bring in your skill. Let's bring in the skill we've learned from previous lesson to factor out this quadratic expression right here. This quadratic expression from what we've learned in the previous lesson, it's a 2-variable quadratic expression. It has leading coefficient 1 whatsoever, but mainly important, it's a quadratic expression with 2 variables. So we've learned our techniques and we've learned the AC methods or whatsoever the methods right here. But as I'm doing this here, I highly recommend anyone who follows along with this video to factor this quadratic expression on your own using the methods you have learned from the previous lesson. I don't need you to look at to discover anything fancy. But so now, from what we have learned previously, I can see that I can factor this into, well, there are 2 pairs of parentheses, and I can simply have x minus y in product with x minus y. And so, assuming that anyone viewing this lesson has already mastered the skill of how we can factor a quadratic expression in 2 variables, and so I can just skip short the steps right here, run short in the steps, and this is the final answer of how we arrived our quadratic expression into a factor product. But now, similar to the one I just brought up in this particular lesson right here, we realize, wait a minute, this final factor form right here is indeed one particular factor, but being twice here, being written here twice, or it's just one. These 2 factors, another way of saying it, these 2 factors are identically the same. So we have our right to rewrite this, to re-express this as that's only one factor, x minus y, but square. It's just simply, we do the usual work up to this point, and then our observation further tells us that, hey, we can rewrite this since it's just one factor being repeated. So we just rewrite it as a x minus y as one factor, but square. Just like I could have brought up this quick argument earlier, like say when you have 2 times 2. Well, elementary students write 2 times 2 and write the answer equals 4. But for us here, we know a little more algebra. 2 times 2 is expressed as 2 squared. We have another way of writing it. And yes, numerically 2 squared equals 4. But sometimes we don't always have value, we don't always have numerical value, so we write a 2 times 2 as a 2 squared. That's what this is. 1 identical factors, but appear twice. Okay? We write it as the factor square. And so now after that argument, I've come to another realization right here. So anytime we have this exact quadratic expression, we can just cut it short and make a final conclusion. It's just simply x minus y all squared. And so this is another perfect square trinomial. 3 terms. It's a trinomial, a quadratic expression that can factor into a perfect square. So this is another trinomial, a perfect square trinomial. So now among the perfect square trinomials, there are 2 of them. One of them is the x squared plus 2xy plus y squared that can be factored into, in factor product, x plus y all squared. And another one, x squared minus 2xy plus y squared. We got 2 separate trinomials right here. Different, they slightly differ by that sign right there, but this particular trinomial over here factors into x minus y all squared. All right, so I have explained and show how I have derived, and the point is I want to show that anyone who's viewing, who's learning from this lesson can also do the same with what I was doing on the board here. But so now, once we have come to concluding the two, and we discover the two perfect square trinomials, what's good about them? How can we apply them into the factoring? Okay, how can we apply them into factoring? Now, I have to point out at this point that the perfect square, each of the perfect square trinomial itself is already a special product, because the product being a perfect square and factor out, it comes into those trinomial. That's why we call them the perfect square trinomial. But we don't just want to stop our learning right at that point. We want to expand our understanding even further. We want to understand what we can do, what else we can do with those that we have recognized, with those two, the special perfect square trinomials that we have discovered. Okay, so now allow me to bring in a demonstration problem right here. So let's call that problem 1. So I bring in a problem so that it brings in so that you can learn the technique, the way how we can apply, and you can see how we can apply the perfect square trinomial into a factoring a quadratic expression. So for this problem 1 right here, let's just simply say we are instructed to factor. And what we have here is, how about a 4x squared minus 12xy plus 9y squared. So in this problem right here, with this problem, I bring in just simply a factoring problem. Okay, just simply a factoring problem. So, but I want to show how we can apply our understanding about the trinomial, polynomial, the perfect square trinomial, is how we can apply this understanding as a formula to quickly factor the polynomial we've had on the other board. So, as the simplest ground right here, this polynomial, this quadratic expression can just simply be understood as any one among those infinitely many quadratic expressions out there. This is just one among the infinitely many quadratic expressions. So you can still use the AC method or whatever method you have learned. It's a quadratic with 2 variables. It's leading coefficient other than 1. So you can just stick with still stay with the method you have learned from the previous lesson. I'm not saying no to that. This is just what we're about to do here. It's just an expanded understanding, just some extension of the way, just a way to extend your understanding, more tools for you to be able to factor a quadratic expression right here. All right. So of course, keeping in mind that we can still do the usual method that we've learned from the previous lesson. But now, as we go along the way, this is what I want to see right here. This is what I want to show you right here. Now, observation is telling me that, so observing this polynomial, this is what I see. The first term, and that's a lot of time when I teach this, I recommend my students to do that. The first step, I'm observing the first term. The first term, 4x squared right here, can be expressed as a 2x all squared. You can pause the video and verify me. Your algebraic understanding, your algebraic background is strong enough, is mature enough for you in order to verify what I'm saying here. 4x squared is understood, is exactly equal to 2x all squared. Well, quickly as scratch work, it's 2x times 2x. And that's why it's 4x squared. And so there you go. Our observation is telling me, before I proceed into the usual methods, I observe the polynomial. I recognize that first term can be written as a perfect square. Now moving on to another observation. How about in this next observation here, I label number 2, I'm going to observe the final term right here. The final term from our quadratic expression. It's a 9y squared. 9y squared, similar argument, can be written as a 3y all squared. And at this point right here, you can easily verify, because the argument is very similar to what I've done in the first observation. So 9y squared equals 3y all squared. So the last term of our quadratic expression here is also a perfect square. Okay? But that's not enough signs to ring a bell about your quadratic here is a perfect square trinomial. Let's do this. Let's check with the third observation. So after having the first two observations here successfully passed right here, we want to check with one more step. How about the middle term? Now, ignoring this, let's ignore the sign here. Let's just, when I'm looking at this, observing a quadratic trinomial like this, right? We just simply look at the first term, the last term, and the middle term without worrying about the sign. And so the middle term without the sign is, it reaches 12xy. But 12xy here is indeed 2 times, I had to purposely write that in red ink right here, 2 times 2x and times 3y. It's just an observation. I've been making it clear that what I'm doing here is simply an observation I can notice. And so I recommend that you do the same way. We learn to observe the quadratic expression that we're having. So everything here is just what we observe and we realize. So I observed the first term and I realized that the first term is a perfect square. I observed the last term and I realized that the last term is also a perfect square. And I observed now the middle term, and what I realized is the middle terms here from our polynomial, from our quadratic, falls exactly into the formula 2 times 2x. 2x came from here. The first term before square, okay, times 3y. The last term before the square. That's what 2xy is. Okay, and so now, after the 3 observations here, and I laid down the steps, that's at least my own thought process, that's how I would do right here. I'm coming to a conclusion as following. Thus, starting 4x squared minus 12xy plus 9y squared, it doesn't hurt to rewrite it. So I'm rewriting that as, now I'm running out of space and I don't want to write into the next space right here, so I'm just writing that in the next line. So this quadratic expression is equal to, first term we have our right now to rewrite it as a 2x all squared. Middle term here is a minus, so now I'm going minus 2 times the 2x times 3y. That's what we realize about the middle term. And I'm going to rewrite the last term here as a 3y all squared. So now, my purpose of showing this, and this is everything I'm doing here is in the brain process, right here. It helps you in explaining for anyone viewing the lessons of where these come from. Okay, but now, let me point it out for anyone viewing this lesson. We can think about the 2x, scratch word right here, we can think about the 2x is playing in place of a big capital X. Because there's a x squared, the big capital X minus 2xy plus big capital Y equals x minus y all squared. So think about it, in our particular problem, as a problem that we apply what we've learned here, then the 2x is, or can be substituted for by the capital X. And so, and then the 3y can be thought of as in place of the capital Y right here. And then the 2 times 2x times 2 times 3y, that is exactly 2 capital X, capital Y. So in this case right here, I realized that, wait a minute, so if I made that argument as 2x is a substitution for the capital big X, and the 3y is a substitution for the capital big Y right here, then my setup right here is exactly, this step is just optional, capital X squared minus 2xy plus y squared. All right, but then we have learned, and I've noted that on this board right here, now this special product we have done right here has had its unique factor form, x minus y all squared, x minus y all squared. And so now into our problem, that means, yes, it doesn't hurt to rewrite, so it equals x minus y all squared. And so now that means x, capital X, is substituted by the 2x. So that means, formally speaking, in the black ink that I'm really doing, that belongs to the actual problem, I'm seeing that we can produce one pair of parentheses with the square. And then now I have the capital X here is simply just the 2x. Capital Y here is just the 3y. And now it's minus sign between these two. But that's how I have factored my beginning polynomial. So, as a final conclusion, for x squared minus 12xy plus 9y squared right here, that's simply factor into 2x minus 3y all squared. And this is the factor form. This is the factor form of that quadratic expression right from the beginning. All right. So it has been a lot of explanations because I want to present where and why these values, these expressions came from. And so that's why it took some time. But believe me, as you start practicing on that, it will come a lot faster. And everything I've been doing here is just about in a mind, in a brain process, in a thought process right here. My aim here and the goal for any instructor teaching this is, the goal here is that at one point the student will become fluent. Seeing this, immediately realize all of this and boom, write down the final factorial answer like that without showing all of these. Okay, so if you're a student of mine, writing down these steps right here, it's just for me to trace down where, in case you made some error. But the main goal for teaching this particular material, I need you to be able to eventually, instantly come from this form into a factorial form as a perfect square. All right. So now, in that way, allow me to bring in a couple of examples. Let's look at example 1 here. So example 1 formalizes the steps. Okay. So we want to factor. How about the first problem I would like to introduce? Right, let's call that part A right here. U squared plus 6u plus 9. U squared plus 6u plus 9. All right. So again, it's an example, but I want to show the thought process right there. So allow me to carry out through this thought process. But the first term, u squared, yes, it's a perfect square. It's a perfect term itself already, u squared. Needless to argue about that. The last term, see, we observe on the first term. And then we move on to the third term, which is step 2 actually. So 9 as a number, but can 9 be expressed as a perfect square? Yes, it's a 3 all squared. All right. And the last term, the sign here is a plus 6u, but let's only worry about the coefficient itself and the variable part. So 6u itself right here. Can I simply see this as, can I simply express this as, see, 2 times the u, that first term before square, and times 3. Is it true? Yes, it is true. Observation tells me that, hey, 6u really is equal to 2 times u, the first term before square, times 3, the last term before square. All right, and so now that means the quadratic expression u squared plus 6u plus 9 in the beginning can be understood as a perfect square first term u squared plus 2 times u times 3, I purposely wrote it like that, plus a 3 all squared. And so this is, again, just for me to explain to anyone viewing the lesson, but my aim is I want you to be able to do this on scratch work, and as you work on these often enough, you're going to get fluent. And so think of the u here. And by the way, before I move to remind you about the perfect square trinomials, it has a plus sign here. It's a trinomial, and think of that as in place of the x. Think of the u in place of the x. Think of the 3 in place of the y. Okay, so now, all right, so this trinomial is the one that matches exactly with our particular problem that we currently have. And so it's x squared, the u was in place of the x. See, the u was in place of the x. The 3 was in place of the y. Okay, and then so we got 2 times u times 3, and that is the same as 2xy. And this form right here is the one that, as I said earlier, exactly matches with our problem. And so on Scratchword, I can see that this is x squared plus 2xy plus y squared. So the formula that we've seen on the other board there, we'll factor this trinomial, this perfect square trinomial, into x plus y in parentheses all squared. So in that way, now it gives us a perfect drive right here. X is u, so now my trinomial becomes in factor form. U for x plus, but 3 for y, so u plus 3, and then all of that perfect square. So u plus 3 all squared. And so now the final conclusion here, u squared plus 6u plus 9 indeed turns out u plus 3 all squared. So we have just now factored our perfect square trinomial. And so again, I've done a lot of explanation, but my aim is to have you in one day fluent with all of these thought process right here, and be able to go boom, one step from that perfect square trinomial, immediately get into that final form right there. And that's the aim for me to have for any one of my students. And that's not just me. Any instructor teaching this will be looking for that goal. All right, so let's call this part B of our example 1 right here. I would like to just simply bring in another problem right here for you to bring in to gain more experience on your learning on this. So in the way how I'm seeing this, it's a polynomial, it's a quadratic expression, more precisely, leading coefficient 1 and only one variable. But anyway, that's just fancy understanding. What I'm seeing here is, as far as observation, I can observe that, hey, the first term, x squared, needless to say, is already a perfect square form. The last term, at step 2 right here, observing the last term, it's a 1. You can always have that expression 1 equals 1 squared. You can always have that property right here. And so 1 square happens to be a perfect square as well. The last term happens to be a perfect square. And then so the middle term, let's observe the middle term right here. The middle term, aside from the sign, 2x by itself is the same as 2 times x. The reason I brought in this problem because I keep having students mistaken, but I just want you to realize and reinforce that anytime you don't see an extra factor, it means 1. So 2x is the same as 2 times x times 1. 2 is part of the formula times x, the first term before the square, times 1, the last term before the square. It's all there for us now. So that means our trinomial x squared minus 2x plus 1 can be rewritten as, and again, this is just in my thought process how it's going and how it's rolling, but eventually my aim is to have you all one day be able to skip all of this and go one form right here to the final factor form. That's the main aim. But anyway, so we got x all squared minus 2 times x times 1 and plus 1 all squared. All right, and so now it looks like among the two perfect square trinomials that we have learned here, this one is the one that better matches with that with that particular problem that we've had, where I can see that x, the lowercase x in our problem, is standing in place of the capital X. The value 1 is standing in place of the capital Y in our formula right here. And so 2 times x times 1 right here can be understood as 2xy. And so this formula here, once we see the connection between the substitution and the current formula right here, then this formula is the better one. And so that means I can see this as the x squared as the capital X squared minus 2 capital X capital Y plus y squared. And so the formula says this can quickly factor into x minus y all squared. And so now in that understanding, I can just now easily see x is the lowercase x substituted for that minus because of that minus sign right here. The minus sign goes to minus between the two, minus 1 all squared. All right. So as a final conclusion, really, this is the one that matters. X squared minus 2x plus 1 simply equals x minus 1 all squared. That's how we're doing it. Okay. And so once again, my aim is to have you be able to work fast, extremely fast on these thought process right here, and just simply write down your final product of a perfect square trinomial factor into a perfect square. All right. All right, and let's now look at another special product. This special product is famously called the difference of two squares. All right, so let's find out what exactly a difference of two squares is before we can bring that into a factor form, into a factor product. Okay, so allow me to bring in a quadratic expression, x squared minus y squared. And I highly believe that somewhere in class meeting or either in some other additional exercises, I'm sure I brought in these problems right here. But for you to factor as just a traditional technique, meaning the technique that you've learned from the previous lesson, not the technique I'm about to show here. So let's not worry about it being called the difference of two squares or whatsoever. All I need you to see is this is a quadratic expression. That's a square, that's a square. It's a quadratic expression in two variables. Okay? Now, a little bit unusual from what I've been doing is that I use capital letters again. But then that shouldn't be the main point of the problem. Now, more commonly, we have been seeing quadratic expression with 3 terms. This one here has only 2 terms. Okay? So, that's where it's becoming a little worrying for anyone learning this. So I recommend to see this as x squared minus 0 xy, all capital letters right here, even though I purposely wrote them a little smaller than that 0, the coefficient. So 0 times xy plus y squared. Now we have our happy 3 terms quadratic expression. And so now in the usual technique we've been learning, we ignore one of the 2 variables because it's a 2 variable quadratic expression. We just simply ignore one. Right? So with your techniques you have learned from the previous lesson right here, then this quadratic expression can be factored into x minus y times x plus y. And once again, in case you don't remember how I have done that in some of the earlier in-class examples or in some of the examples prior to this lesson, this one specifically, x squared minus 0 xy minus y squared, we can think of that as now applying what we've learned from the previous lesson. We can ignore the y variable. It's just me, I tend to ignore the y variable. So we turn that into x squared minus 0x minus 1. And so again, leading coefficient 1 now, 1 variable. And so we just think about 2. See, put an x here, put an x there. We think of 2 factors of -1. See, -1, think of 2 factors of -1, including signs that sum up to 0. So those have to be -1 and 1. -1 and 1. So -1 and 1. That's how we've been applying, that's how we apply what we've learned from the previous lesson. And now with the actual presence of the other variable, our actual one is an x minus y, because 1 times y, and then here 1 times y, so x plus y. Okay, and so this is just scratch work. That explains the reason why x squared minus y squared can be factored using the method we've learned prior to this lesson. It factors into x minus y times x plus y. So that's how I derived it. But so we all certain realize an ultimate conclusion. So x squared minus y squared. The reason this setup here has been called a difference of two squares because there's a difference. There's a difference. Only two terms. It's a difference of two squares, two perfect square. All right. So the difference of two squares right here can easily be factored as a formula now. That's, hey, x minus y and x plus y. And we have come to another formula that will later on lead to a lot of factoring problems right here. That opens up a lot of easy factor problems right there. All right, so the difference of two squares will be factored easily into x minus y in parentheses times x plus y. All right, so let's now look at an actual problem to see, and so that we can learn how we can apply the difference of two squares into some real-time factoring problem. So let's now call that problem number 2. All right, so in this problem 2, I would like to demonstrate how we can factor a quadratic expression here using the difference of two squares now as a formula to do the factoring. Okay. So again, keep in mind, you can always use the methods that we have learned prior to this lesson because you can always see this or think of this as 16x squared minus the 0xy minus 9y squared. You can always do that. 16x squared minus 0xy minus 9y squared and stick with the traditional AC method that you've learned from the previous lesson. But the point now is that after we have learned the formula about the difference of two squared, there's a much faster way of factoring this problem. So aside from doing this, now allow me to point out my observation. So with our given quadratic expression, two terms only, and we don't need to do the fancy 0xy. Let me point out a couple of observations. Right. The first thing I realized, the first term, 16x squared, I can write that as a perfect square. 4x all squared. The last term, now I'm putting aside, I'm putting my attention away from the minus sign because it will always be a minus sign. It's called a difference of two squares. So the operation existing between the two terms here are always minus. So that's something that we never have to pay attention to. But the next term after the subtraction sign is a 9y squared. Make sure to recognize that. And I do recognize that here as a perfect square, 3y all squared. And that's how I'm seeing this quadratic expression here as a perfect square, as a difference of two perfect squares. All right, so. And again, I have to emphasize, everything I'm doing here is just my own thought process that I wrote it down and present that in front of my viewers, my students, so that you can see, you have some explanation. But my aim is to eventually have you be able to instantly do these in your thought process, in your own thoughts, in your own mind. So that means the 16x squared minus 9y squared is understood as 4x all squared. See, we have found one perfect square in a difference with 3y all squared. So now we clearly have displayed the difference of two squares. Okay, so the difference of two squares. Allow me to again remind the formula. The difference of two squares, the difference of two perfect squares can be factored easily into x minus y, no square, no square, just first power x minus y in parentheses in product with x plus y. Two factors almost looking identical, but one of them is a minus sign, the other one is a plus sign. So I can see that if we apply this formula into our current problem, then 4x is playing in place of the capital X in our formula right here. And the 3y is playing in place of the y in our formula right here. All right, so in that case, see, I realize that this is the 4x, is the capital X. So it's capital X squared minus capital Y squared because 3y is in place. It's substituted for the capital Y. And so that means we can factor this into x minus y times x plus y. And again, everything I'm doing here is just in a thought process like that. And so I hope you feel free to keep practicing, but at some point I hope you reach that goal that you can instantly bring this to a final answer. So 4x minus 3y, because that's what x minus y is, 4x minus 3 little y, in product with 4x plus 3y. All right, and so final conclusion, 16x squared minus 9y squared can be factored easily into 4x minus 3y times 4x plus 3y. That's what it is. All right, so now I would like to bring in example 2 right here. And the first problem in example 2, let's try to factor 25a squared minus 9. 25a squared minus 9. So, again, let's observe it. So now observing this quadratic expression we have. First thing I observed, 25a squared can be observed as 5a all squared. Anyone can verify me this at this point in your learning. Or you feel free to pause the video and verify me that. The next observation I can see, the 9, last term in our quadratic expression there, can be understood as a 3 all square. So the point is to recognize each of our terms as a perfect square. All right, and so now once we have realized this, then what I'm seeing here, 25a squared minus 9 can be written as 5a all square. So there's one perfect square. There's a difference, and then the 9 here is a 3 all square. And so now we clearly display the difference of two squares. Yeah, the difference of two squares. Okay, and so once again, the difference of two squares has a famous formula. The difference of two squares can be when we're factoring it, it's factored into, the difference of two squares factor into x minus y as one factor in product with x plus y. And so now with our current problem in the example part A right here, then I'm looking at 5a is being put in place of the capital X in our formula. And then the 3 right here from our problem can be put in place of that capital Y variable. And so in that way, that can be understood as x squared right here minus y squared, and x squared minus y squared is factored into x minus y times x plus y. Okay, and so now our difference of two squared, our actual difference of two squared here is indeed, now with that form applying where 5a is for x and 3 is for y, we're looking at 5a minus 3 in parentheses with 5, and in products with 5a plus 3. All right. So that's the final factor form. So as an ultimate conclusion, we can just simply write the final answer here. I didn't do this throughout the demonstration problem, but now we can do that here. Because remember, anything I've been doing here is just to represent, it's just to show you, to present you the thought process. But I would like, as my goal, I would like to that some point in your learning you will become fluent, and all of these can just be done in your mind. All you do is just write the final answer. So here it's going to be 5a minus 3 times 5a plus 3. All right, and in this problem right here, let's look at another problem where we're asked to factor, and so it's a quadratic expression. And so what I want to see about this, there's a difference. And so let's observe our quadratic expression. The first term, u squared, that's also the first step. The u squared can be seen as a perfect square, u all squared. I tend to have parentheses around anytime that I raise power or put things in substituting values in or things like that. Now, step 2, I'm going to observe my other values right here, 25. Ignoring the sign, because the sign will always be a difference. It's a difference. So we want to find out whether we want to detect whether these are both perfect squares. So 25 is 5 all squared. And so now I can see that u squared minus 25 can be understood as u all squared minus 5 all squared. Now it's clearly showing the difference, the exact same expression, but it's clearly showing the difference of two perfect squares. Okay. All right, so now back into this board right here, I can see that with this formula, the difference of two squares, which factors into x minus y times x plus y, I can see that in our particular problem, then u is being put in place of the capital X, and 5 is being put in place of the capital Y in our formula. And so now with this reminder, now let's go back to the other board. You can see this as, see, capital X squared minus y squared, and of course as a reminder, x minus y times x plus y as the final factor product. So now advancing with our actual problem right here, see, the difference of two squares factor into that, but u is being put in place of x. So now I'm looking at u for x minus 5 substituted for y. The minus sign comes out with that formula. And then I have u, because x plus y, but u is substituted for x. U plus 5. 5 is substituted for y. Okay. So my final factor product, this is our final factor product. So u minus 5 times u plus 5. And this is the final factor form of our quadratic expression here. Simply two terms. All right, so now let's look at the difference of two cubes right here. Okay, it's another special product. It's another special product among all of the special products we are learning. So now, as the name is saying, the difference of two cubes. So let's say I have a perfect cube, x cubed right here. For x can be whatever variable that is, but the difference. So we have learned. In my teaching, I've always been teaching the difference of two cubes after you've learned about the difference of two squares, because you will be able to see some similarity. So a perfect cube in the difference with another perfect cube. Okay, so that's how it's called, a difference of two cubes right here. Okay, all right. So now for this one right here, let me just bring you straight into the factoring formula. Now this difference of two cubes, factoring it's going to factor into x minus y, no power here, or precisely power 1, and then multiply with another factor in parentheses. Now x squared plus xy plus y squared. All right, so it's a formula for us to factor. But let's look at where it comes from. So how do we know that x cubed minus y cubed can be equal to, in factor form, x minus y times x squared plus xy plus y squared? The way, for this case right here, I would like to verify this equality right here by simply, I'm going to FOIL out the left-hand side. It's got more term than just the usual FOIL, but doing the distributive law like that. So x is going to multiply with x squared, with xy, and y squared. The y term on this, the minus y term, is going to multiply with y squared, with x squared, xy, and also the y squared. So that's what I meant by the foiling like that. So doing the foiling or doing the distributive laws right there, we're looking at x times x squared giving me an x cubed, x times xy giving me and it's a plus sign, so it's x squared y. X times y squared gives me, and it's a plus sign, with plus sign it gives me x y squared. And then now minus y times x squared gives me minus y x squared. Minus y times xy gives me minus x y squared. And minus y times y squared gives me minus y cubed. And so now, after distributing all of the terms right here and expand it out, I can see that I have a couple of opposite terms here. The xy squared and xy squared, these are opposite terms. We can cancel them, okay? And then x squared y or x squared y, they are indeed just a little bit of a rearrangement here, but they are indeed opposite terms again. And so after foiling out this product on the right-hand side, we realize, wait a minute, so it reduces down to x cubed minus y cubed. And so that means this factor of product is indeed, after the distributive law, equals to the difference of two cubes. And that's how we know the difference of two cubes on the other way around can be put back in factor form as this form right here. Okay. All right, so now we've had the difference of two cubes as a formula. And this fundamental one here says anytime we have the difference of two cubes, it can be factored into whatever you're seeing here. Okay. Let's see how we can bring this and apply that into a more flexible problem in factoring. So allow me to bring in problem number 3. All right, so in this problem, allow me to demonstrate how I can apply the difference of two cubes formula into factoring it. So we are asked to, in this problem 3, we are asked to factor out 27u cubed minus 125u cubed as well. Okay, so here's how I'm observing my polynomial here, and notice this is no longer a quadratic expression, it's just simply some polynomial, power 3 polynomial. So first term of the polynomial, the 27u cubed, at least what's easy for me, and I hope as you have seen me doing this often enough, you will also recognize it easily enough on your end as well. But 27u cubed is the same as 3u all cubed. So I've just now observed and recognized that 27u cubed can be understood as 3u all cubed. It's a perfect cube right here. Okay, now I'm going to further observe the next term, 125w cubed. 125w cubed can be thought of as 5w all cubed. 125w cubed is the same as 5w all cubed. So now, from that observation, I can see that 27u cubed minus 125w cubed can be understood as 3u all cubed minus 5w all cubed. And so now, the formula is still being right here on the board. Now we clearly have shown that this starting problem right here indeed turns out to be a difference of two perfect cubes. So the formula to factor the two perfect cubes is right here. See? So what I can see here in this problem right here. Then 3u, in this formula, 3u is being placed in place of the capital X in our formula. And then 5w is being placed in place of our y in the formula. So with the formula right now here, I'm not going to worry about writing down the red ink part because it's easy enough. But let's just repeat the formula. So x minus y, but x is 3u, y is 5w. So x minus y, we have 3u minus 5w. That's how we repeat the formula right here in factor form. And now it comes to the next pair of parentheses for a bigger factor. So I'm going to use brackets for now. X squared, but 3u is being put in place of x. So x squared means we have 3u, but in parentheses squared. 3u all squared. And then the formula says plus x times y. Now x is 3u and y is 5w. So it's just going to be 3u times 5w. That's how I'm putting it in. See? X minus y in parentheses x squared plus xy, one more term, plus y squared here, but y is substituted by 5w. So 5w all squared. My writing may be a little hard to read here, but it's 5w all squared. All right. And so now after working all of these out and then rewriting all of these expressions, here's how it comes. We will come to (3u minus 5w) and multiply in parentheses the 3u squared from my 3u all squared from my earlier board, from my other board. It's going to now be 9u squared plus now 15uw plus 25w squared. And so as a final conclusion, (27u cubed minus 125w cubed) can be factored into 3u minus 5w times in parentheses 9u squared plus 15uw plus 25w squared. And that's our final factor product of the difference of two cubes here. But what challenge for us was recognizing each of these as a perfect cube. All right, so let's look at our example 3 right here. And the first problem in here I have, let's factor out 8x cubed minus 1. Okay, and so once again, very similar to steps I've been doing earlier. The thought process here should be we're observing each term here. So first one to observe 8x cubed, I can see that it's 2x all cubed. So 8x cubed is exactly equal to 2x all cubed. It's a perfect cube now, after recognizing that. 1, the last term right here of our polynomial can be also understood as 1 all cubed. And so now upon realizing that, we can just rewrite our expression here, 8x cubed minus 1. We can rewrite that as 2x all cubed minus 1 cubed. And so that now shows we have a difference of two perfect cubes right here. And so now comparing this with our current formula, I can see that 2x is being substituted for the capital X in our formula of the difference of two cubes. And then the 1 is being placed in place of that y variable in our formula. And so now we can just see that x minus y according to the formula. So x is a 2x minus y minus 1. Okay. And then in parentheses, how about for now, let's just write it as brackets right here. So the 2x being square plus, and now I have 2x multiplied with 1 and plus 1 all square. All right. And so now in our next step right here, 2x minus 1 is one factor. The other factor we have is going to be 4x squared plus 2x plus 1. And so as a conclusion, 8x cubed minus 1 is factored into 2x minus 1 times 4x squared plus 2x plus 1. Let's now look at another problem in our current example. So part B of example 3, let's look at u cubed minus 64. So again, I'm observing my terms right here, observing the terms of my polynomial. I recognize that the first thing, u cubed is a perfect cube, u all cubed. And then 64, my second term right here, my next term, 64, is recognized as 4 all cubed. And so now from that way, I'm seeing u cubed minus 64 can be written as u r cubed minus 4 cubed. Now it clearly displays the difference of two cubes here. And so referencing this with our current formula, we can see that u is playing in place of the x and 4 is being put in place of the capital Y. Think about we applying this, if we would apply this exact formula into our problem right here, then u would be put in place of the x and 4 would be put in place of the y variable in our formula. And so now in that case right here, now when applying that, see the difference of two squares says in factor form it's x minus y, but x equals u and y equals 4. So we have u minus 4 instead of x minus y. And then I'm going to open square brackets for now. See, x squared, but in our problem right here it's going to be u squared plus, now xy, but x is u and y is 4, so it's going to be u times 4, and then plus one more term, 4r squared. All right, and so now at this point right here we can have u minus 4 in parentheses u squared plus 4u after rewriting it plus 4 squared is a 16. Right, and that is our factor form for this u cubed minus 64, or as a final conclusion. All of those we have done earlier was in the thought process, but my aim here is to have you quickly factor u cubed minus 64 into u minus 4 in parentheses u squared plus 4u plus 16. All right, and that is the answer as of the factor form of u cubed minus 64. All right, so now let's look at the sum of two cubes. The last one among the required special products that we need to learn right here, the sum of two cubes. So again, similar to the difference of two cubes that we have learned earlier, let me just get straight into the formula. So the sum, as it's set right here, then we have two perfect cubes added together. So the sum of two cubes, some y cubed, capital Y cubed, plus some capital X cubed, that can be indeed factored as x plus y, capital X plus capital Y in parentheses times capital X squared minus xy plus y cubed. So ladies and gentlemen, this is the formula how we can factor out, we can indeed factor out the sum of two cubes. All right, and let me make similar arguments so that I can show how this formula came about. So x cubed plus y cubed is stated to equal, in factor form, x plus y times x squared minus xy plus y squared. Okay, so the only way to verify this equality is to FOIL out or distribute out all of these x and y terms right here. So I'm looking at x times x squared, x times xy minus xy. I meant x times y squared, y times x squared, y times minus xy, okay, and y times y squared. Okay, and so doing that, I'm going to have x times x squared gives me x cubed, x times minus xy gives me minus x squared y. X times y squared gives me plus xy squared. Y times x squared gives me plus y x squared. And notice how they are already opposite signs. And then y times minus xy gives me minus xy squared. And y times y times y squared gives me plus y cubed. And so lots of opposite signs happen right here. We got x squared y minus x squared y and positive y x squared. These two are indeed opposite terms, so they cancel out each other. Now these two are opposite terms, so they cancel out each other. So that's how we reduce it down to x cubed plus y cubed. And that's how it shows that, hey, x cubed plus y cubed right here can be put into factor form as written here. Let's look at this problem here so that we can see how we can apply our formula for factoring a sum of two cubes into some better work right here. So here we want to factor 8u cubed plus 27w cubed right here. Okay, so in how I'm seeing it, observing this, I can see that by observations, I can see that 8u cubed, first step right here, can be understood as 2u all cubed. So now 8u cubed is realized as a perfect cube. Like that. 27w cubed is understood as 3w all cubed. So it's another perfect cube right here for that. All right. So now from that point I can see that 8u cubed plus 27w cubed can be understood as a sum. It's a sum of two perfect cubed, 2u cubed plus 3w all cubed. Okay. So referencing this formula into our particular problem right here, I can see that 2u is being put in place of the capital X in our formula to make some correspondence. And then 3w is placed in place of our capital Y. All right. And so in that way, now I can start utilizing this formula right here. So the sum of two perfect cubed, x cubed plus y cubed, I can go x plus y as part of the formula. But x is 2u and y is 3w. So instead of x plus y, I'll write 2u plus 3w. All right. Now I'm going to produce brackets. So x squared, but x is 2u. So I'm writing 2u all squared. So x squared minus xy, but x is 2u and y is 3w. So I'm putting together 2u in parentheses times 3w. And then plus. And then now in my formula just now I realized I had a typo right here. So y squared, but y is 3w, so it's 3w all squared. All right, and so now with that, I'm just simply going to rewrite it. So 2u plus 3w, and then now I'll have, see, 2u all squared is a 4u squared minus 6uw and plus 9w squared. And that's how I have factored out I have put my beginning polynomial into factor form. And so as a conclusion, I'll have 8u cubed plus 27w cubed can be factored into 2u plus 3w in product with 4u squared minus 6uw plus 9w squared. And that's how I have factored out this polynomial. All right, so let's look at some example right here. So in this example 4, part A of the example, we want to factor x cubed plus 8 right here. Okay, so the work is done similar to how I've done the problem that we've had right here. So observing the first term of our polynomial, we're looking at x cubed is a perfect cube, x all cubed. 8 as the other term is understood as a 2 all cubed, right? And so now that means x cubed plus 8 is understood as x all cubed plus a 2 all cubed. We have a sum of two perfect cubed. And so now referencing this into our formula, I can see that x, lowercase x, is being put in place of a capital X in our formula. And 2 is placed in place of our capital Y. All right. So now realizing that x cubed plus 8 is a sum of two perfect cubes right here, we're just going to repeat the formula. So x cubed plus y cubed is factored into x plus y, but instead of x plus y, we got lowercase x plus 2. So 2 is for y. So x plus 2, okay, in parentheses, and I'm going to produce brackets here. So I'll have x squared, but it's lowercase x this time. So x squared minus, and then x times y, xy. So x times 2, right? And then plus, and now I'll have a 2 all squared, okay? And so rewriting all of the expressions here, I'm looking at x plus 2 in product with x squared minus 2x plus 4. All right. And so as a final conclusion, the sum of x cubed and 8 right here, so x cubed plus 8 can indeed be factored into x plus 2 in parentheses x squared minus 2x plus 4. And that's how we have factored out the sum of two perfect cubes. All right, and let's look at our part B of the example, the current example. Just another problem for us all to try right here. So we got 125th a cubed plus 1. All right, and so what I'm seeing here as observation to our problem. So 125a cubed is understood as 5a all cubed. 125 itself is a 5 cubed, and then a cubed right here, so 125a cubed is understood as a 5a all cubed. The second term, 1, is understood as a 1 all cubed. All right, so now 125a cubed plus 1 can be understood as 5a all cubed, a perfect cube plus with 1 cubed, another perfect cube. And so now referencing this with our particular formula right here, difference of the sum of two cubes right here, I can see that 5a is being put in place of the capital X and 1 being put in place of the capital Y. And so now the formula for the sum of two cubes, we can state it out. It's x plus y, but x is 5a and y is 1. So instead of x plus y, we got 5a plus 1. And now I'm going to produce a square brackets, all right? And 5a all square, because it's x squared. So x squared means here 5a all square minus x times y, but x times y is 5a times 1. So 5a times 1 and plus. Now y squared, so here we're looking at 1 all square. And so now rewriting our expression, 5a plus 1 stays the same. 5a all square can be rewritten as 25a squared, and then minus 5a times 1, so it's just minus 5a, and plus 1 squared is just 1. And so as a conclusion, 125a cubed plus 1 can be factored as 5a plus 1 in product with 25a squared minus 5a plus 1. And that's how we factored this polynomial using the sum of two cubes.